channel. I'm Nwobodo Maureen Amuche, and I'm currently working at the TheSparksFoundation as a data science and business analytics intern. I've successfully completed my first task as an intern, and I'm here to show you how I did it. So for today, we'll be using supervised machine learning for our prediction. I'll be predicting student scores based on their study hours. To complete this task, we'll employ simple linear regression since it involves just two variables. You know that linear regression is a supervised learning technique in machine learning used to predict the continuous relationship between an independent variable and a dependent variable. In this case, you can say that the number of hours is independent variable, which is usually in the x-axis, while the scores is a dependent variable, usually on the y-axis, because the scores of each student is dependent or influenced by the number of hours each student spends studying. For our setup, we'll be importing all required Python libraries. It's always a good practice. Organize the imported libraries by its functionality. It makes our work look neat and organized. The first thing we have to do is to import NumPy as MP. NumPy is usually used for scientific computation. After that, we import Pandas as PD. Pandas is used for data manipulation. So, for our data visualization, we import Matplotlib as PLT. Finally, we have to import the Python library we use to model our algorithm, and that will be our linear regression. We import it from sklearn. The next step after importing our required Python libraries is to import the data. And for us to import our data set, we have to import it from a remote link using this URL. In order to do that, we use PD, which stands for pandas.read.csv, because it's a CSV file, then in bracket to put our URL. When you run it, you see that we successfully imported our data set. The next step is to load our data set in order to see the number of columns and a few rows of our data set. In order to do that, you use the name of your data set .head. In this case, the name of my data set is s_data.head, and I added 10 in brackets, so that's why I can see the first 10 rows of my data set. But if I want to see just the 5 first rows of my data set, I'll remove the 10 and run it. I'll see the first 5 rows of my data set. Then if I put back the 10 in brackets, when I run it, what I'm going to see is the first 10 rows of my data set. So note that if you don't want to see the first rows of your data set, so that you want to see the last rows of the data set, instead of using .head, use .tail. So remove .head and type in our name of our data set .tail. Since we have them, when we run it, we'll see the last 10 rows of our data set. So if we don't want to see the last 10, we want to see the last 5, remove 10, run it again, we'll see the last 5 rows of our data set. Yeah, but for the purpose of this task, let's take it back to .head. Also have our 10 in bracket. So when we put it, then we'll run it again, we'll still go back to having our first 10 rows of our data set. After that, we'll explore the data, and in order to do that, we'll plot the distribution of scores. Remember what I said earlier, that because our studies is independent, it will be on our x-axis, and because the percentage score is dependent on the our studies, it will be on our y-axis. So what we'll do is we'll label our plots. I'll start by labeling our x-axis as hours studied, while the y-axis is labeled percentage score. Yeah, and for the whole plot, we label this as hours versus percentage. If you look at the plot, you see the relationship between the percentage score and the hours studied. As the hours studied is increasing, so percentage score is also increasing. Yeah. The next step is to prepare the data. In doing that, we divide the data into attributes and label. And attributes and label is something as saying X and Y axis. So X will be for the hour studied, while our Y will be for the percentage score. After that, we split our data into train and test sets using scikit-learn built-in train test split method. Note that when splitting our data, it's important that we have more trained data sets because it helps our algorithm to have enough data set to train with. Ideally, your train set can either be 70% while your test set is 30, or your train set can either be 80 while your test set is 20%. But for this task, we'll be using 0.2. That means it's equivalent to 20%. So our test set is 20% while our train set is 80%. So after splitting our data set into train and test sets, the next thing is for us to train our algorithm. So for us to train our algorithm, when we run it, it's printed algorithm trained. Then after that, we'll plot our regression line. Note the regression line is simply a single line that best fits the data, in terms of having the smallest overall distance from the line to the different points. This line can better explain the relationship between independent and dependent variable, and is referred to as the best fit line. So looking at this plot, we'll see that this is our regression line. Yeah, a regression line, and it's showing clearly that the more hours spent studying by the students, the more their score. Then the next is for us to do a prediction. They want to check the prediction that if the student study for like 1.5 hours, 7.4 hours, 5.9 hours, what will be the resultant percentage score? So we've trained, so we want to do a prediction. So this is what we want to predict. Then after that, when we run it, you see we are done with our prediction. Then the next thing is now to compare our actual value then the predicted value. That's our actual value that came with our test set. So when we look at this now, see these are actual value and these are predicted scores. First one is 20, the actual value is 20, while the predicted one is 16. And the last one, see, the actual one is 62, while the other one, the predicted one is 60. So there is not really much difference between the actual value and our predicted value. That's said our algorithm really did well. Then again, we are told to find out or to predict the score of a student who studied for 9.25 hours. So when we run it, we got 93%. As we want to check what if it's not, if the student studies for just 5.25 hours. When you run it, you see that we have a lesser number, that's 58%, telling you the higher the student study, the more the score. So for the purpose of this task, let's have return it to 9.25. then we run it, go back to 93.69%. Then finally we evaluate our model. Why is it important to evaluate our model? To know generally how our model did. And we evaluate the model by importing metric from sklearn, and when we did it, we imported it, we run it, and realized that our mean absolute error is 4.183. So our algorithm really did well, didn't do so badly. So this brings us to the end of today's task. Thank you so much for sticking with me to the very end. If you enjoyed the video, do like, subscribe and comment in the comment section. Bye for now, and see you next time.